Good morning, students. It is Tuesday, March 24th, and welcome to Earth Science Today. Here's your learning targets today. I can name and explain at least 4 pieces of evidence for continental drift. Okay, we're getting into continental drift. I'm going to give you, I think it's, my list is about 7 pieces of evidence. So I'm saying that when it comes time for some sort of test, summative assessment, can you give me back at least 4 of them? And can you explain how they tell us that the continents are actually moving? So, number 1. There's a guy by the name of Alfred Wegener. His work, I think, was published in about 1912. So we're talking a little over 100 years ago. And he noticed, as a lot of other people noticed, that the continents, when you look at a map of the world, when you look at a globe, the edges of some of the continents seem to fit together. And most notably, I think probably most people notice that if you look at the edge of Africa, I have a globe. I should bring it over. So if you look at the edge of Africa over here, and you look at the edge of South America over here, boy, it sure looks like Brazil would fit right into that notch. And if you cut these out, and the story goes that Wegener actually took a map and cut it into pieces and put it together and saw how they fit. Now, he's not the only one to notice that, but Wegener suggests other pieces of evidence to go with this. Now, there's an animation here. Hopefully that will work. And maybe it is not. Well, sorry, I didn't realize that wasn't going to work until now, but we will just move along. I'll see if I can find another animation. But basically what this was showing is showing all the pieces of the Earth lined up together into one supercontinent that Wegener called Pangea. I bet you've heard that name before. And then those continents, or that supercontinent, broke up into pieces, and those pieces drifted apart until we get to their locations today. So, one piece of evidence is our puzzle piece. Now, by itself, just the coincidence that continents sort of look like they fit together, that's not a strong piece of evidence, or that's not proving continental drift by itself. But again, that's one piece of evidence. We're going to look at several. So, number 2 we're going to look at is fossils. Alright, so try to just process this a little bit. Let's say you're a fossil hunter, and you are kind of specializing in one particular ancient plant or animal, and you have mapped out where every known occurrence, every fossil ever found of this plant or animal. And what you find is, on the coast of South America, there's a cluster of dots. And on the coast of Africa, there's a cluster of dots. And you ask yourself this question: how is it that this creature could have existed on 2 different continents a couple thousand miles apart, and maybe nowhere else on Earth? And you ask yourself, did this creature have the ability to cross the ocean? What if the answer is no? You say, no, there's no way this animal could have crossed the ocean. What if, and here's where Wegener is coming in with his continental drift hypothesis, what if those two pieces of land, way back when the creature was living, were adjacent to each other? Now, the creature didn't live on two separate continents. The creature lived in this area. This is where all of the fossils are found. And since that creature lived, that got split apart. South America drifted over that way, Africa drifted over that way, and now we find the fossils separated by a couple thousand miles of ocean. This has been shown in multiple cases where you can find evidence where the same creature was on two different continents which are currently very far apart. And you ask the question, well, how is that possible? Number 3, we're going to talk about mountains and rocks. I'm going to back up my picture just a little bit. There are places where you find rock formations on the coast of South America, and you find rock formations on the coast of Africa. And the rock formations are same type of rock, the same age, and showing all the same sorts of characteristics. And you say, well, how is it that you have rocks just of the same type and age, on opposite sides? Because you would think that those rock formations would have been formed at the same time. And so the thought is that, yes, those rock formations formed at the same time, but at the time, those continents were together and have since split. And there's numerous places that you can find evidence of that. The Appalachian Mountains that go up along the eastern part of the United States continue up through Canada and parts of Greenland and over into, I think it's northern Scotland. You find the same types of rocks. So if I pull up this globe again, we're talking about a mountain range that comes through the United States, up through here. Similar types of rocks here, but we find the same types of rocks over here. So if that were together at some point in the past, then that makes sense. Again, there's numerous places on Earth where we find examples of this. So go back to this mountains and rocks slide. So mountains / rocks, we could talk about both cases, of similar type and age are sometimes found on different continents. So Wegener thought that these mountains and rocks were formed together and later drifted apart. Number 4, we're going to talk about glaciers. Now, I want to make sure you understand what a glacier is. So, I have an example here where, let's say we're in the mountains, and it snows. And it snows through the winter, and we get piles of snow. And then spring comes, summer comes, but let's say the climate at this time is such that not all of the snow melts in summer. So when you get to the next winter, there's a little bit of snow left from the previous year, and then it starts snowing some more. And we cycle through that, we keep going. And every year, the snow gets deeper and deeper and deeper. Some of it melts in summer, but not all of it melts. And so this snow gets deeper and deeper, and the weight compresses that snow, turns it into ice. And eventually the weight is so great on it that that ice actually is getting squeezed and flowing out over the land. And that glacier then, that mass of ice, gets pushed and actually flows down through the mountain valleys, grinding everything in its path. Well, that's a cold climate situation. Now, glaciers sometimes leave evidence behind of their passing. Like I said, when the glacier's grinding everything in its path, there's sometimes scratch marks and various features that are left behind by glaciers. So what if you find glacial evidence in a place that today is very hot and near the equator? Well, it tells you that at some point in the past, the climate had to be very different. Now, yeah, we know that the climate changes, but it's always going to be hot near the equator. So it's not just a little shift in climate. What Wegener would describe with this, or the piece of evidence here, is that the site that you're talking about must have at some point in the past been in a colder region of the Earth. So maybe it was closer to the poles of the Earth, and when the glaciers were forming, and since that time the land has moved, and now we have land that's got past evidence of glaciers that happens to be in a more tropical location. Number 5, coal seams. Okay, coal, yes, that's that rock that can burn. Evidence of coral reefs, coral fossils. These things are sometimes found in cold Arctic type locations. But those are things that can't form in cold Arctic type locations. Coal is the leftover mass that's been transformed from huge amounts of plant matter, like in swamps. Tremendous amount of plant growth. The plants grow, they die, they get buried in the swamp, and that plant matter gets buried deeper and deeper and squeezed and transforms over a long period of time into coal. Well, to have that kind of plant growth has to be a warm climate. Coral reefs only form in warm climates. So when you find coral fossils, maybe off of, say, the coast of Alaska, you say, that doesn't match. So Alaska would have had to have been substantially warmer. Now, Alaska's too far north to be that much warmer, so the question would be, was it at some point in time further south? Now, don't quote me on the Alaska thing, but it could be some other piece of land. At some point in time, could it have been further south? Could it have been in a more tropical location? So when we find coal and coral fossils in cold climate locations, it's again evidence that stuff must have moved. I think this is probably the hardest one for us to understand. I'm going to talk about magnetite and polar wander. Okay, so first of all, magnetite is a natural mineral whose crystals act like tiny magnets. So it's a natural mineral that we find in the ground, but the crystals are magnetic. So magnetite forms from lava flows. Lava and magma cooling. And as the magma or lava cools and crystallizes, because the magnetite crystals are magnetic, what happens is they line themselves up with the magnetic field of the Earth. The Earth has a magnetic field. So basically, when that crystal cools and crystallizes, it kind of locks in what was the direction of the North Pole. Now, what we find is around the world, there's old rocks that contain magnetite crystals, and the magnetic field in those rocks doesn't point to the current magnetic north. Now, we know that the crystals, when they formed, had to be pointing north. So that leads us to either the magnetic pole, the North Pole, moved, which is possible, or the rocks moved, or both. Where it really gets to be stronger is the fact that if you look at different points on the Earth, they all had to be pointing to the same place. And so if we find rocks on different parts of the world that were formed, if we date the rocks and say that, well, okay, they date to roughly the same time, when they formed, they both should have been pointing north. And if we look at their magnetic fields now, the way those rocks are pointing, and one's pointing this way and one's pointing this way, we say something happened. Because they both had to have been pointing north when they were formed. So this tells us that the rock itself must have moved. Yeah, the pole might move some too, and we know that today, that the actual magnetic pole of the Earth does move around a bit. But the rocks must have moved. All right. The last piece of evidence I'm going to give you is a modern piece of evidence. Okay? We now have GPS. There are dozens of satellites orbiting the Earth, and that's just from the United States, and different agencies around the world have their own satellites. So really there are hundreds of satellites orbiting the Earth, and many of those are part of GPS. I have in here that the U.S. has 31 GPS satellites. Several other countries have their own. I looked that number up a couple of years ago, so I'm not sure if it's accurate right now. But when I said dozens of satellites, and those satellites communicate with our devices on Earth. So if I hold out my phone and turn on the GPS features, now my phone's right now taking the video, so I can't do that, but it's communicating with multiple satellites out there. The ability to measure time is very accurate, but we can measure time to trillionths of a second with atomic clocks. And so basically the phone is calculating its distance from, let's say, a satellite over there and a satellite over there and a satellite over there, and when it puts that all together it says, oh, you are exactly in this spot on Earth. Now the GPS technology has gotten very, very good. My phone isn't accurate enough to, pinpoint down to the centimeter, but there are devices out there that can give very, very accurate measurements. So with GPS, we can actually look at and monitor and see that different parts of the Earth are moving at different speeds relative to each other. We actually have, all those other things that we had were pieces of evidence that Wegener was putting forward. I don't know if all of those were proposed by Wegener, but they're pieces of evidence for continental drift. GPS, in my mind, kind of closes the book. Yes, we now know that the continents are moving. We can measure their movement. If I return to those other pieces of evidence, each one by itself probably seems like, so what? That's a coincidence. But when you start putting those multiple pieces together, it starts building a pretty strong case that, yeah, the continents are moving. Now, this idea didn't catch on very quickly, and the problem is no one could explain how the continents could be moving. And we have to go all the way for about another 50 years after Wegener proposed some of these ideas before we really started getting the evidence, and the scientific community came around to the idea that, yeah, he's right, the continents are moving around. But we had to get a mechanism for how that happened. And that's not an easy thing to understand, really. Let's see if this one works. This is a website based on that actual GPS data. Okay. So you see a map of the west coast of the United States. Here's Washington State, Oregon, California, Nevada. And there's all these arrows on here. And these arrows are showing relative movement based on GPS data. So we have, if you see, much of California, the outer edge of California, is moving that way, and the length of the arrow represents how fast it's moving. And you see that over here, the rest of California is also moving that way, but not as fast. And so that creates some problems. When one part's moving faster than the other, we're going to get a little bit of binding, and once in a while it's going to break loose and we're going to get earthquakes. Oh, yeah, you've probably heard of this thing called the San Andreas Fault, which basically follows those lines right on up from Southern California right up to San Francisco. We see that different parts of the earth are moving in different directions. And it tells us that, yeah, the plates, the continents are moving around. All right, so I've given you several examples of continental drift, or evidence for continental drift. I had 7 different things. You can go back and review them. I'm expecting you to be able to give back to me at least 4. Now, you can do more, but at least 4 where you can not just list it, but say, all right, this is how this shows that the continents must be moving. You can explain it, right? That's your goal today. So you took some notes on this, and I'm going to have you do a little reading assignment. Of course, everything's posted and will be posted in Google Classroom as soon as I get this done. I apologize, I'm a little bit late. I'm looking at the clock and it's about 8:18, and I know I'm supposed to have this up by 8 o'clock, but things happen. All right. As always, communicate if you're having problems. Take care of yourselves. Be safe. I hope to see your faces soon. Hey, consider stopping in for one of those hangout chats if you get a chance.